again, Chapter 6 starts on page 339. Normally he breaks it up into about 10 different areas. You'll notice it's only in 5 because, again, this is a shorter chapter. All right, we've talked about this divide and conquer mentality here, the idea of taking a program and breaking it up into smaller, manageable pieces. All right, and I've given the example before. It's like if you live alone and you come back and you got a house, you come back to your house and you're like, this house is a pigsty. You kind of fool yourself, for lack of better words. You go, well, maybe if I clean the kitchen, then maybe if I clean the bedroom. So you sit there and you apportion it out into pieces. And by doing the pieces, you're still getting the whole job done. And that's, again, what this chapter is about. And the author mentions, we've used these already. You've been using event handlers, but you've been putting all the code directly in your event handler. That's going to change starting in this chapter. All right, we've used some built-in methods like messagebox.show and try-parse. As we're going on, we're writing more and more of our own methods. Okay. Again, as I mentioned, some languages call them methods. Some languages call them subs, some call them functions. Depends on the language. All right? And it's funny, Java calls them methods, but then uses the word function. So every language is different as far as how it handles this stuff. Technically, if you're using an object-oriented language like this one, it should be called a method. All right, so we don't want to do this, where we stick everything in the world under our button-click event. Instead, we want to be calling different methods and having those methods do the work. That's, again, the concept of modularization. All right, I already mentioned to you before the break, a void method is a method that doesn't return anything. So you don't have to have a return statement in it. Technically, and I believe C# is one of those languages that you can literally put in return semicolon at the end, and it shouldn't complain. All right, there are languages out there that even if you don't return anything, you have to put a return statement in. This is not one of those languages. All right. So again, a void method does its task, it terminates, and it doesn't return anything. This is kind of important right here. If you take a look, this is from page 341 in the book. I went over this with you a little bit before, but this is called the method header right here, where it says private void display message. This is called the access modifier. There are 3 different access modifiers that we'll get into at the end of the semester. There's public, there's private, and there's protected, which is sort of a cross between the two. But we'll talk about those later in the semester. That's the return type, and again, if you're not returning anything, it's void. If you're returning a string, it's the word string there. An int, it would be int there, etc. That's the name of the method, and in the parentheses, you can put in anything that the method requires. One of the things that you're going to see in this, that we'll start talking about, again, when we get into this later, is you can have 2 methods with the same name. You can do that. But if you have 2 methods that have the same name, then what goes into these parentheses must be different. Because the system has to understand how to differentiate between the 2 if they have the same name. And the way it does it is by what's in the parentheses. Those are called the method arguments or the method parameters. Sometimes they go by different names, but usually arguments or parameters are the ones that are used most often. So he explains here about access modifier and return type, method name, and the parentheses. All right. You already know that your method body, this language is a block structured language, and your blocks are delineated by open and closed curly braces. That's what he says right there. You know this. As it says, methods usually belong to a class, so you must write a method's definition inside of the class. In other words, with just the stuff that we were looking at just a couple minutes ago, all right, in here, we couldn't sit there, right here, I'm just going to grab that last method that we put in here, this one, and I'm going to copy it. And I'm going to try to put it out here. All right? And notice I'm getting an error because it's outside of the confines of the class. So the system doesn't even know that it exists. So when you create stuff, it has to go within those curly braces that delineate the entire class. And you look at it, why do we get that error? Expect class, delegate, enum, interface, or struct. It doesn't know how to handle what you gave it. as a method call. Now, this may be the most important part of this lecture is right here, what I'm going to give you in the next couple minutes. And that is if I go back up again to our calculate button, right there. This is a method call. And if I go up a little higher, this is a method call. The difference between the method call on line 98 and the method call on line 142 is the one on line 98. That's a void method. Does that make sense to people? You're not returning anything. There's no return, so boom, it's just a method call. In this case, we don't have anything in the parens. We could have anything we needed in the parentheses to do what we needed it to do. We could do that. Now down here, this must return something. Why? Because we're stuffing it into a variable. And whatever this returns, whatever gets returned from oil loop charges must be the same type as this. Must be. Because if they're not the same, the system will say, you know, I don't understand what you're trying to do. And when you say this is new, we haven't had this, yeah, you actually have it in here. Does this make sense to everybody? We're calling a two-string method, and when we're calling it, we're passing it in that parameter. You can call two-string and not pass in anything. You can just leave those parentheses empty, or you can put in something like this. All right. Some of the methods that are available in the language, you have to pass something, and some you don't, and sometimes it's optional. So he's got, he starts real simple, a go button. To me, that's kind of silly, but that's fine. But he explains all this other stuff. This is, depending on your point of view, is either kind of a cool program or kind of a silly program. But literally, as you'd guess, when you click switch light down here, it's going to be on or off. All right, and he's got just a couple image views that he uses in order to do a couple of images for lights. And it's not very hard code. It's not a lot of code. You should be able to take a look at that and figure out what it is. All right, then he gets into talking a little bit more about top-down design here on page 348. As he mentions a little later, it's also known as stepwise refinement. Okay, it's one thing about most computer people. If you give them one way to do things, they'll look as hard as they can to find other ways. And in much the same way, they can't agree on terminology. Literally, when I was at Blackhawk maybe 2 years, and we had some money left in the budget, and I managed to parlay. I got to go to a conference. Wow, we got to go, yeah, but it was in Kansas, so it really wasn't, you know. But so I got to go to a conference in Kansas with another instructor who was an accounting teacher, but he was also new programming. And we listened to people there. It was a conference for the C programming language. One person said they wanted to make a change to the language. And they said what they wanted to do. And there was a panel up there. There were about 10 people. And he got done speaking, and the guy next to him said, that is idiotic and asinine and maybe one of the stupidest things I've ever heard in my life. This guy got up and hit the other guy. I'm like, this is really cool. I get to go there, and I get a floor show. Right? But that's how much these people believe in these things. So when you see different words and different terminology, it means different things. It usually means the same thing, but different people use it differently. If somebody else was giving you this lecture, you might not ever hear top-down design or stepwise refinement unless they grabbed it out of a book. Some people just call it divide and conquer, rather. All right. I just call it modularization because that's what we're doing. All right. Arguments then on page 349. An argument is any piece of data that you pass to a method that it needs in order to do its job. And I've given this example before. Maybe not to you guys, but I've given it before to classes. It's like if my 18-year-old daughter comes home and I'm so upset because her room is a pigsty, which it is, but I say to her, clean the room. If I say it like that because she's a little smartass because she was raised by one, all right, she might say, what room, Dad? All right. But if I say clean your bedroom basically is the parameter. It's the information she needs in order to be able to do her job. Because if I say clean the room, and she walks into my room that's clean, says it's clean. Well, you didn't tell me which one you wanted to clean. All right. And sometimes a method, in order to do its job, needs nothing. All right? And again, sometimes it's optional. I just showed you that with toString. All right? Imagine that there's a built-in method that's available in C# as part of the math class. It's called sqrt, for square root. If I'm going to call the square root method, what do I have to give it? If I call square root, what does the square root need? Can I just hit the square root key on my calculator and get something? Why? What does it need? How about a number? So that's an example of a method that needs a value. And the value has to be of a certain type. I can't write a program and ask for a square root and put my name in there, because it won't make sense to the system. All right? And if I write a method like this, you've seen message box. That's the simplest message box there is. It's going to have hello in there. It won't have any icon. The button will say OK, because you get that by default, and it won't have any title. So again, this is an example of a method where you can put as much in there or as little in there as you need. Again, they mentioned it's also called a parameter. Okay? And he gives you an example. It's a pretty simple example. He says you're going to call a routine that's called display value, and you're passing in the number 5. It could have been a variable you passed in, but there it's just a number. So notice, this is called right here, when you call the routine, that's called an actual parameter right there. All right, I'm on 349 at the bottom of the page. That's an actual parameter. When you use it in the routine itself, it's called a formal parameter. They don't have to have the same name. That doesn't, does it? The actual name is 5. The formal name is value. It can have the same name. In this case, it wouldn't make much sense. But if I had a variable here that was called x that had a value of 5, it can be called x here, and it can be called x there. That's fine. When you set this up in here, you have to not only give it a name, but you have to tell it the type. But in here, you don't tell it the type when you call it. You leave the type off. All right, and he shows a bunch of different examples, and he's got a little demo program. Again, it's fairly well written. All right, and I've said this kind of thing to you before. I'm just going to say it one more time. I hate to just keep repeating the same stuff over and over again, but that's why I like it when you do course evaluations. If you're like, I wish that you wouldn't do your own programs. I wish we wouldn't have class. If enough people come in and say, I don't like it that we do a program as class, then I wouldn't do it the next time. I try to listen to what people say. I can't change it for you guys, but the chances are in fall, that's the same way that it's going to be. All right, and it's got to be that way in fall, because you're learning 3 new languages in fall. If you're a full-time student here, you're learning C, and if there's enough time, also a little bit of Objective-C and Swift. You're learning ASP.NET, and you're learning PHP. All right, and you're doing that in addition to the Advanced Java class and whatever happens to be in the Advanced Website Development class. I'm not sure what that'll be right now. All right, so he's got another tutorial here where he shows cards. The thing that's kind of neat too about modularizing and creating modules like this, notice what he's got. He's got show cards. Not really a whole heck of a lot to it right there, but look at that. Would it be that hard to take what he's got right there, make modifications to it, and as an example, make a game of 21? I don't think it would. All you'd have to do, you can keep showing the cards, that's fine, but all you'd have to do would be to keep track of the number right here. All right. Again, just another reason for modularizing. He goes through it, and then he explains what he's doing in every step, and he even goes through the different steps, and before it, he says, this is why I did it this way, type of an idea. All right. And one thing, hopefully, you've noticed as you're starting to go through this is you might go, well, I wouldn't do it that way, and that's good. That's the mentality you should have, and you should start getting. If you say, Jeff showed us how to write this, but I wouldn't have done it that way, then go back and rewrite it your own way. I always remember the second programming class I ever took. I asked that to the instructor. I said, I got it done. And here it is, and I showed it to him, and he said, yeah, that's fine. And I said, but I'd like to redo it because I don't like your specs, and I don't like what we learned in the book, so I want to do it my own way. And he gave me the best piece of advice anybody ever gave me. He said, that's fine, but make sure you make a copy. Because it was not if, but when I screwed it up, I still had the original to go back to. All right, but I learned more doing that. All right, I've already mentioned you can only pass a string in if you're expecting a string. You can only pass an int in if you're expecting an int, etc. All right. Scope, you know what that is already. We've already talked about that. That if I come in here and I create a variable inside of the exit routine, which would be silly, but if I come through here and I type in int age equal 21, I'm going to get the squigglies because I'm not using it any place. All right. But if I come outside of this routine and I try to go into the clear routine and I say age equals 22, I get an error message. And it's red now because the scope of age was just in this routine. It's in between the curlies where you define it. That's why if you define something within these curlies up at the top where it says form, it's between those curlies, which is the top of your program and the bottom of your program. That's why it's available anywhere. All right? And that's what the author talks about in here. Again, you can pass multiple things. Pass as many things as you need. And he talks about naming your arguments, etc. That's fine. This is something fairly new in this language, and some languages allow you to do this. This is page 357. Some languages don't. And that is you can have a default parameter. And please look at this because there's two rules that you have to realize when you use default parameters. First, if you've got default parameters, they must go at the end. If I reverse this and said decimal tax rate equals 0.7m, comma, decimal price, I'd get an error message. I can have as many default parameters as I want. I can have 10 parameters, and they can all be default. That's okay. But if I have 5 that are default parameters and 5 that are not, those 5 that are not must come first. And the system does that because now I can call this, I can call show tax, and I can either pass it price and tax rate, or I can pass it just price. See the difference? And think about it. If I'm writing a program for Black Hawk Technical College, I might want to default the state to Wisconsin because approximately 95 to 98% of the people who come here or who are involved in this school are from Wisconsin. All right? So they show you this, and they mention later that you can call it either passing one parameter or passing 2 parameters. If you only call it with one parameter, then the other one is automatically set to that. And a lot of times there's a really good reason for doing that. So a couple things, and again, default parameters must be literals or constants. So you can't stick a variable in there. You can't have a variable where we just looked at that here. That can't be decimal tax rate equals X. Doesn't make sense to the system. All right. You can provide default arguments for all of them or any number of them. Now, this is probably the hardest part of the chapter right here that starts on page 358. All the variables that we've been working with so far, okay, ints, doubles, etc., when you pass those into a routine, you're passing them by what's called by value. So you're passing a copy of them into the routine. So any changes you make, you're making to the copy. You're not changing the original. But that's not always what you want to do. So this call by value means that you're passing in a copy. And he shows this here. He's got int number equal 99. Then he calls change me. So he says int number equal 99. So this should say the value of number is 99, correct? Then he calls change me and he passes number. But notice it's not a return right there. So he's not returning anything. So inside of there, he changes it to 0, and he prints it out. Then he prints it out again when he comes back. So notice, it's 99, it's 0 in the routine, but then it's 99 again because he passed it by value. So all he changed here was a copy of it. He didn't change the original. Well, again, that's fine, but what if, he says passing by value works in most situations, but not in all. So if you want to pass and have it be permanent, as they show starting on page 360, you pass by what's called reference. Reference means address. You're not passing a copy of it. You're passing the address in memory of where the thing lives. So what you're changing is its value in memory. So when you think pass by reference, think permanent change. When you think pass by value, all right, when you think pass by value, think of temporary change. All right, this is done totally differently for those of you in the next class than Java. In Java, if you use your primitive variables, all right, int, float, double, byte, char, and I'm forgetting a couple, short, long, etc., all those are automatically passed by value, a copy, no matter what. You can't change that. All right? And here you can. You use what are called reference parameters. And it says there are two ways to pass an argument by reference. You can use the reference parameter in the method. You can use an output parameter in the method. What they did was they wanted to give you the power in this language of what you use in the C programming language. But in C, when you pass it, you use an ampersand. When you use it in the routine, you use an asterisk before the name of the variable. And they figured that was too hard for people to understand. So they tried to make it easier. Did they succeed? Well, you can decide. So again, a reference parameter is a special type. When you pass it, it does not receive a copy of the value. Instead, it gets a reference to it. Basically, it gets its memory address. All right, so it's a permanent change. As it says, it's useful for establishing a two-way communication between methods. So you want to call something, you want to pass it in, and you want to change it in there. Notice what you use. You use the word ref, short for reference. Right. So notice they've got set to 0, and they use ref there, and they use ref here. See that? So this is the routine, so you need the word ref, followed by the type, followed by the name, and when you call it, you use the word ref. You don't put the type in there. And if that is a little hard for you to wrap your head around, it's the bottom of 360, then take a look at the program. There's an example program starting on 361 and 362, and then he's got an even bigger one that starts on page 363. All right. He does a really good job of explaining this stuff, right? At least in my opinion. All right, the other way, again, that you can do it, as mentioned here on page 363, is you can use what are called output parameters. So rather than the word ref, you can use the word out. And you might say, why would you give us two choices? Why ref and out? Out is also something, those of you who are in the class with Jim Schmidt, the 147 class, when we don't get to the point in that class, but when you actually start writing some code, you can write code, basically MySQL type of code. And out parameters means that you can use it, that you can make changes to it. There's an in, there's an out, and there's an in-out. In means read-only. I'm sorry, yeah, in means read-only, out means write-only, and in-out means read-write. You say, well, I'll never remember that. You don't have to. All right, then starting on the bottom of page 367, he goes in and talks about what if you want to return something. Okay, I may have said this to you before, but I'm saying it again. In this language, how many things can you return from a method? The answer is 0 if it's void, or 1. One thing. That one thing can have all sorts of different components in it, but only one thing. And if you return a method, a value from a method, you must put the type in there. All right, so in other words, number, does this make sense to people looking at this line right at the bottom of 367? Number has to be an integer. That makes sense? Because you're calling int.parse. All right. If you call double.parse and number was set up as an int, you'd get an error message. And the author is showing it to you in here. Okay. All right. Writing your own value returning functions, well, that's what I just tried to show you, starting on page 368 here. That's what we did both in that calculator program and when we went through our own iteration of the Joe's program. It says you write a value returning method the same way as you do a void, except two things. You need a return statement and you must specify something other than void for the return type. So this right there cannot be void if you're returning something. There's a good example. That's about as simple of a routine as you can write, right there. And it's pretty much, for lack of better words, it's kind of classic. All right, it's private. It returns an integer. It's called sum. It has two things passed into it, and you add those two things and return them, and that's whatever the call is going to be, it gets stuffed into the value of the return. So if you call this and you passed it in 10 and 12, it's going to add 10 and 12 and return 22 to whatever call this. And he gives you a pretty simple example here, starting on the bottom of page 369. Enter your age, enter your friend's age, and this is your combined age. And he's got the code for it on all the next page and a little bit on the top of page 371. Now, if you're still having problems with a distance converter, you notice here, in tutorial 6.4, which starts on page 372, the author does a little bit of work. It's not the same one you did, but it converts cups to ounces. The idea is pretty much the same. You can return anything, any data type from a method. So, if I've got this, if I write a Boolean method, what must it return? True or false? Some kind of either the word true or the word false, or a Boolean variable that has the value of true or of false. Okay. You may or may not be aware of this. You may or may not care. But what some languages allow you to do is, when you're working with Booleans, false is typically 0. And true is typically anything that's not 0. So some languages allow you to actually work with numbers instead of true and false. This isn't one of them. So simple thing here. They're using a message box, but the key thing is that's the Boolean expression. If it's true, you could return true, that the number is even. Otherwise, you could return false, saying that it's not even. And that's what they show you right here. Ideally, too, when you look at this, you're starting to realize why you use good variable names. This is pretty much a self-documenting program when you look through it. And he has one last program, modularizing input validation with a Boolean method. So he's going through to make sure you put a number in here, etc. for any. So this is very similar to stuff we've done. All right, he says you can return a string. Fine. And that's pretty much it for the chapter. So one last time, I'm going to turn up to this page here. This, again, is the next assigned program for you. All right? And as I mentioned to you previously, I've had people take this in all sorts of different directions. I was watching some TV show. I don't remember what it was. But I was watching where some people do the rock, paper, scissors, and they say shoot. You know, I'm still waiting for the day that somebody turns one in, and when they have to shoot, they're going to have a little gun. And literally, I'll get something like that. And it's not really going to surprise me, to be honest with you. All right. But you are to put in a couple simple graphics. Again, you can use either the ones provided, and they're out there, or I provided other ones. Or, you know, and you probably have done this already yourselves. You know, you can go out to google.com. You know, you can go out to images here, and I didn't even do this, but I'm sure if I put in rock, paper, scissors, yeah, you might have done that one already, right? Yeah. There's rock, paper, scissors, lizard, you know, for Star Trek. I don't care what you do. All right. And this is where I took some of these from, but there are a lot of different ones that you can use. Any questions on anything that we've gone over today? That's all that I have. All right, so it'll be lab all next week.